Hello everyone, I am Deepti Mishra, Assistant Professor in Modern Institute of Pharmaceutical Sciences, Indore. Today, we will learn about non-aqueous titration or the basics of non-aqueous titration. So, what is non-aqueous titration? The non-aqueous titration is the titration of substance dissolved in solvent other than water. So, most of the titration are performed in aqueous media, but many substances like therapeutic agents are mostly not only poorly soluble but also weakly reactive in water. So, the non-aqueous titration is a titration of the substance which does not dissolve in aqueous solvent and a non-aqueous solvent is required for it. So, it is the most common titrimetric procedure which is used in pharmacopoeial assay and serve as a double purpose and also is to eliminate the two problems. First is it is suitable for the titration of very weak acids and very weak bases, and it provides a solvent in which organic compounds are soluble. Needs of non-aqueous titration. So, we need to perform the acid base titration in non-aqueous due to the analysis too weak acid and too weak base. Reactants or products are insoluble in water. Reactants or products react with water, and titration in water does not allow a sharp endpoint. Non-aqueous titration, advantages of non-aqueous titration. So, basically the non-aqueous titration is used for the weak acid and weak bases. So, the organic acid and bases that are insoluble in water are soluble in non-aqueous solvent. A non-aqueous solvent may help two or more acid in mixtures. In the individual acids can give the separate endpoint in different solvent. And many substances are not soluble in water, can be easily titrated in water-free media. Weak bases and weak acid easily titrated, and substance composition that cannot be separate determined in aqueous media can often be titrated in non-aqueous media. And non-aqueous solvents are used for the titration of very weak acid and weak bases can not be titrated in water. So, non-aqueous titration are simple and accurate method. Basically ये यूज़ इसलिए किया जाता है just because इसका एंड पॉइंट शार्प हो और जनरली वीक एसिड और वीक बेसिस के लिए ये यूज़ किया जाता है. Then solvents used in non-aqueous titration. So, for the solvent selection, non-aqueous titration, the solvent selection is mainly based upon the following parameters. First is solubility of the sample, nature of the sample, should produce sharp endpoint, should have the high dielectric point constant, should be a low toxicity, should be easily purified, should be inexpensive. So, basically 4 types solvent are used in non-aqueous titration: Aprotic solvent, Protogenic solvent, Protophillic solvent, and last is Amphiprotic solvent. So, first is Aprotic solvents. Aprotic solvents are most important solvent in this titration. These solvents are chemically inert and they work as a catalyst. These are not reactive with the reactants, these are work as a catalyst. Like the solvent increases the rate of speed in reaction and also decrease the rate of speed in reaction during the chemical process. So, these are the inert chemical in nature, and examples of the aprotic solvents are chloroform and benzenes. Actually, aprotic solvents, which is not proton donor or not a proton acceptor. So, example of the aprotic solvents are chloroform and benzene. Protogenic solvent. Protogenic solvents are the acidic in nature and they can donate the protons and they can enhance the strength of weak bases. The example of protogenic solvents are HCl and H2SO4. Third one is protophilic solvent, are basic in nature which possess the high affinity for proton. An example is liquid ammonia, amine and ketones. Amphiprotic solvent are those solvents, they work as a both mean, protogenic and protophilic. They can donate the protons and accept the protons. It means amphiprotic solvent are acidic and basic in nature, and they are accept the protons and donate the protons. An example of the amphiprotic solvents are water, alcohol and weak organic acids. So these all are about basics of non-aqueous titration. Thank you.